Well, I have a problem to pose to you. Let's say I've captured this rat here on Earth, and I want to do some experiments with it up in space to see how its mass will change after doing these experiments on it. And I say, well, here on Earth, that's not a big deal because I put this rat on a balance and I can get its mass, or I can get its weight. Here, let's say this rat weighs 120 grams. So on Earth, this rat weighs 120 grams. It has a mass of 120 grams. Terms used interchangeably here on Earth. But when you go other places in the universe, that's not so. Because if I go to the moon, now while my rat still has a mass of 120 grams, now the weight of this rat would only be 20 grams because the gravity on the moon is only 1/6 that of Earth. Or if I go to a place like Mars, now my rat would still have a mass of 120 grams, but now it has a weight of 40 grams because the gravity of Mars is only 1/3 that of Earth. Well, let's go out in space. Let's say I'm going around the Earth in the space shuttle where we're in a weightless environment and things are floating around out there. Balances like this and pan balances won't work because the object would just be floating on it. How am I going to calculate the mass? How am I going to get the weight of this rat after I do my experiments with it? Well, we have to come up with a unique way of doing it. And that unique way is called an inertial balance. We use the properties of a band, the properties of springs, to measure an object's mass. And what we would do is take this inertial balance, we'd calibrate it on Earth so we know the properties of this spring or this band. And then in space, we would take my rat and I'd put it on this inertial balance. I would strap it in so it doesn't float off the balance. And then by oscillating back and forth and by timing the amount of time it takes to oscillate one full oscillation, I can then use mathematics to calculate the mass of that rat. And therefore, we're using math and science in space to do things that normal mechanical devices here on Earth can't do.